Okay, so Steve, are you there?
Yes, I am. I'd first like to test the fact that my mute button works. I'm going to say something rude about Carlos. Hang on just a minute. All right, did you hear what I said about Carlos?
I did. How could you? God.
Thank you. Just checking. I need to know when I can hit the mute button and cough and not actually blow out the speakers there in the room.
Okay, can everyone hear him? All the way in the back. Is that good? Is that all?
Can everyone hear what I'm saying?
Okay, Steve, I've already started the recording.
I've seen that. Great. I'll just get started.
Very good. My name. Away from the podium. It's all yours.
It's all mine. Oh, I thought you could stand there. Never mind. Lip sync. Okay. My name is Steve Kuenzli. This is a presentation that, I'm a solution architect for Microsoft. I work in the U.S. public sector group of Microsoft Consulting Services, specifically focusing on enterprise search. My background is I have been working in search for over 10 years now. I started back in the old days with Alta Vista and moved to some public sector customers, and then wound up working for FAST, and then FAST was acquired by Microsoft, and so I've been working with this kind of technology for a long time. The concepts, surprisingly enough, haven't really changed in the last X number of years. So what I'm talking about will be generally applicable, but it is also specifically at FAST Search for SharePoint 2010 as the current version of the product. Let me just page down and see where we're going. Okay, so just to set the stage, there are 4 primary use cases for enterprise search, what we call the enterprise search maturity model. The first one's basic search, small number of documents, typically done at a departmental level, and this is the get the product, install it, throw it on a couple of servers, and you're done kind of an implementation effort. A little bit more elaborate is where you get to enterprise search, where you start talking about more data volume and a wider variety of data sources that have to be presented in a single search page. People look at this as this is your normal corporate environment where you might have some file shares, you'll have SharePoint data, you might have a database application that you integrate or something like that, but it's primarily your intranet search across the corporate assets. The next level is where things start turning into programming, which is what we're going to be talking about today, programming in FAST Search for SharePoint. What we call a Unified Access Platform, or UAP, not a great acronym, but what it does is this is where people start saying, wait, the enterprise search was nice, but I need this specific bit of information added to it, or I need this specific presentation of my search results provided from my user group within the enterprise populace. And frequently, some of those things will be what we call search-driven applications. These can be Tier 1 or mission space applications where it's highly specific and highly focused. These could be done on a standalone basis, or they could be done on a built on top of what we call a UAP. Now, when you start incorporating multiple indices or multiple applications on top of a single search index, what happens is you've got to be able to manage your data model. Your information architecture becomes key. And so we're going to talk about information architecture. We're going to talk about developing applications. Whichever of these environments you fall into, the development kinds of activities we're talking about primarily fall in the bottom 2, UAP and SDAs. If anyone has a question and I don't hear it, kick Carlos and you can jump up and yell into the microphone or something. I'm happy to take questions if somebody wants to, if you want to do that. Otherwise, I'll just keep going. Unfortunately, the headphones that I have aren't picking up a lot of the room noise right now, so we'll just keep going. So you've seen these slides.
Steve,
SharePoint.
No problem. Yeah, go ahead, and if any questions come in, I should interrupt you.
Okay, great. SharePoint server, FAST Search for SharePoint sits beside SharePoint in terms of the implementation, but at the presentation layer and at the content layer, it is the same integration point. BCS on the content side and the query object model, in essence, on the left-hand side. What you're getting with FAST Search for SharePoint, you've probably already seen these, but the big thing is this one on the upper right. I'm going to see if I can do this. Oh, are you seeing the highlighting?
No.
No, never mind. Okay. Darn. Okay, gonna try to use the drawing tool. I messed up. The advanced content processing is the big thing here. That's something that you don't get in the SharePoint server, the search within SharePoint that's native, rather than the FAST Search. The FAST Search gives you some access, and we're going to talk about that right in a moment. People search is still done through the old the regular SharePoint search. So when I walk into an application development situation, or when I'm walking, actually not even that, just any search implementation, I'm asking 5 questions. And these 5 questions have been, this is something that I've been doing for 12 years in search, asking these same questions. And they are the same ones that have been there all along. The first one is, what am I searching for? When I type something in that query box, I'm looking to get a list of somethings back. And the question is, what is that something? In a typical basic search or enterprise search environment, you're getting documents back. You know that they're documents. They're files in it. That's how people are thinking of it. It's just a repository search. If you're building an application, these might be specific entities. They might be people, places, things. It could be cars. It could be products for sale. It could be some logical entity that needs to be modeled with some set of what we call managed properties. Down at the bottom there, you see that we've got 5 fields representing this particular index schema. The thing that comes back is represented by a list of name-value pairs in these managed properties. And they are the cumulative total of these 5 questions. Defining those fields tells us what the functionality is, all the way from the back-end repository all the way out to the UI, because we're starting at the UI level and working our way back. So first question is, what am I searching for? A document has a title, probably has a URL or a file path. It's going to have a body, right? It's going to have the converted text of the document itself. It's going to have a date. It's going to have an author, things like that. Those things go to find the what of what I'm searching for. Second thing is, how do I filter those results back? So I might need to be able to distinguish documents that are about the Green Bay Packers, that are about football, whether it's English Premier League football or whether it's NFL football. So if I need to filter results that way, I can do it. The question is, which fields do I need control on? If I need something that says what country this came from, I can deduce off of that. But if I'm doing a football application, then I'm probably going to say, is this soccer or is this football? And I'm going to distinguish between the two, and I'll map things that way. The third question I ask is, how do you sort things? Now, people think about database sorts and they go, okay, great, we've got all the different columns and we can sort things this way and that way and the other. A search application, the typical out-of-the-box enterprise search style applications tend to not use a lot of different sorting criteria. The first and the most powerful one is, of course, the relevance sort of the document list that comes back. The next most popular one is show me the most recent documents that come back. So you've got date and you've got the relevance. I've been in a number of situations where geographic data is tagged onto each of the documents in there. And so there's a formula sort mechanism that's available in FAST Search for SharePoint that I've frequently seen to do geographic distance. So that's kind of the third one that I see in practice. Other people will throw size and other things out there, but again, it's sort of one of those things where the more you put out there, the users still really only focus on 1 or 2 usually, and it depends on their use cases. So first one is, what do I search for? Second one is, how do I filter? Third one is, how do I sort them? The fourth one is where we get to some really interesting functionality, which you may or may not be familiar with. I'm going to expect that you're familiar with the concepts, maybe not within FAST Search. We have this grouping question. How do you group the results? How do you slice and dice and make them? How do you drill into that to narrow your search? These are refiners. They used to be called navigators in the old FAST lingo, but we call them refiners, and this allows you to specifically identify attributes to documents that you can know exactly how many documents match this attribute in that field coming back out of your search results. So if you've got 1 million results back, you know that exactly 387 of them were written by, I can't read the name there, but any one of those names. So the last of the 5 questions is, what do you get back when you return your results from the index? This may seem trivial. We've pre-built all of this stuff into FAST Search for SharePoint, giving you a complete functional standard basic or enterprise search application against all of our regular data. We've defined the answer for all of these things for standard documents. You get it, you can tweak it, you can augment it, but I've seen applications that returned nothing but a database ID out of the index because they didn't want to put all of the data into the index. They then, on the search result page, grabbed that ID and hit the database to display the information. Perfectly valid way to do it. In their application, that was the way they chose to do it. So that what returns in a result, URLs, teasers, things like that, the title, the author, that it's all of these are sort of trivial questions or trivial answers in the out-of-the-box installation. But now the question is, I've got an application that I need to build, and that's the direction that we're going. The answer to all 5 of these questions, define the index schema at the bottom of the screen there. Once I know that, I know all the functionality that has to be implemented at the screen, in my document processing pipeline, and how it all maps back into my original data sources. Very powerful stuff. Okay, I'm moving on. So, one of the coolest things about FAST Search for SharePoint, and this is a shameless plug, this is the first product I've ever seen that actually had a management screen for managing those 5 questions right in the administration tool. I've worked with 4 or 5 different products, and none of them let you do it this simply, mapping the properties that are in the index back to the properties that came from my original sources and be able to mix and match them. It's wonderful. It's great. It demonstrates well, and if I got 1 or 2 things to tweak, I can do that. I'm never going to use this screen in a practical implementation. I'm going to go use PowerShell. There are a couple of commandlets in PowerShell, this new FAST Search Metadata Managed Property and the set of the same thing, which are great, but you have to kind of program around them. Well, if you go out to TechNet Script Center, the repository up there, and look for this maintain FAST Search Metadata Properties PowerShell script, you'll find something that will allow you to configure an XML file and basically update, create, and map all of your crawled properties from your managed properties. I would love to ask for a show of hands, but I can't see it. Is it safe for me to say that everyone knows the difference between a managed property and a crawled property?
How many people know the difference between a managed and a shared, managed and a crawled property? Not that many, Steve. We got maybe 3 out of
not that many. Great. A crawled property would be the property as it came from my original source. So if I'm crawling a database, it's going to be my columns in my select statement that came back. They're going to be associated with that database crawl, and I may have a title field in that database. I may have a subject field in my Exchange crawl results. I want to map the subject from Exchange and the title from the database, those are crawled properties, to the title managed property. Because the managed properties are the ones that are in my index. Think of the index logically, it's not implemented this way, but logically as a single database table. I have to figure out, okay, who's using this column for what from each of my different data sources, whether it's a database, whether it's Exchange, whether it's SharePoint. Again, we've done all of this for you out of the box, but it can all be tweaked. And this script allows you to control those things. All right, I'm going to keep moving then. So the idea is we want something that's going to allow us to programmatically tweak the crawled properties as they're coming in, and we'll get to that. That's the preview where we're heading. So, for example, I may have a managed property named latitude. It's a type 5. It's a floating point value. You'll see that it's sortable. I want to be able to sort by latitude. It's a summary. That means it's coming back in my results. It's queryable, meaning I can search for it, so I could do a bounded box query for latitudes. and it's not a refiner, so I turn that off. And the merge crawl properties we set for 0 in this particular example. So that script, which is on, again, the code gallery, I'm going to page up again just to show you that again. The TechNet Script Center repository, I'm going to page down now. That script uses XML, this is just a snippet of it, to do that. So when you're doing an implementation, you've got not only sort of pre-built documentation, but you can use that as your functional implementation script as well. All right. So fast search for SharePoint architecture, starting on the left where people are querying in the upper left-hand corner, we've got all of the things that are going on at the UI level on the custom search center. We've got below that on the left, we've got some query SSAs, search service applications that are running there. On the right-hand side, the far right, we've got some content sources that are being integrated either through the SharePoint or the BCS or Exchange connectors. And then in the middle, you've got this sort of big pink box where it says Fast Search Server 2010 for SharePoint Farm. That is a separate set of servers than your SharePoint servers. And what happens is you've got 4 things that you can do as a developer to update, to modify, to customize this for your environment. And those 4 things, starting on the left, is where you generate the query and where you filter out the results, so at the UI level. Then you have the ability to tune the relevance inside the body of the index. So you can configure the index to have different relevance. You can even configure multiple different ways to calculate relevance. Excuse me. I'm going to skip one and go to the far right. Where we feed custom data, you have control over some of the connectors there. You have the BCS for those for doing any kind of programmatic feeding that you want to do. The most interesting one to me, and the one we're going to spend a bit of time talking about, is where it says Customized Document. This is the thing that you didn't get in SharePoint Search that you get in Fast Search for SharePoint. This is access to the content between the crawl and the index. So before it gets put in the index, you can grab the data and you can look at it, you can decorate it, you can extract things, you can slice and dice, and then you can update the thing that's going into your index, the managed properties in your index schema that's going into your index. You can manage that. We're going to talk about that. We're going to start on the left. We're going to start by talking a little bit about the query and the filtering of the results, how you do that programmatically. At a fairly high level, we can drill as people have questions. So the first thing to think about when you're accessing an index is the query language. Now, FAST has got FAST query language is something that has been developed over the last 15 or so years, and it's an extremely powerful, extremely descriptive way of defining the queries. It's got wildcard support, all different sorts of data types, numerics and strings and date times and things. We've got a number of different operators. We can do fielded access. We can do counts and ranges. You've got all the normal Boolean operators and or not any. We've got a very interesting operator called rank. There's a variant of it called xrank. What this does is this lets you at the query level refine your relevance on this query, just this query. So for example, I could do something where I looked for football and I said I want to boost the relevance for things that are English Premier League. And it would, without changing anything in the index, it would automatically reshuffle all of my NFL documents below my English Premier League documents. Proximity, we have a near and an ordered near. That's what ONEAR is, operators. All of these things go into this example query that you have where it says and or title colon X. So I'm looking for X in the title field or Y anywhere in the document. This kind of syntax is really powerful for defining very specific queries that are application-based. So if I'm going to come in and write an application where I need to do something very specific against a particular data set, you got a huge weapon here for going after your data. Now, when you want to use fast query language, you have to get access to the programming model inside of FAST Search for SharePoint. So there are three ways that you can do query integration in FAST Search for SharePoint. The first is the Federation Object Model, and this is what's used by the normal Search Center. It's the one where you've got all of the different parts, web parts on the page, and you put the query in here, and it fires off to each of the different search result sets that you have, and it handles all that. You have limited access to the keyword query object, which is sort of the core object inside of the programming model where you want to access things. The query object model, method number 2, is where you're actually down there messing with that keyword query instance yourself. And that's where you can begin to put in the full FQL statement the way that you want, exactly the way you want. If you go out into TechNet, you can bing fast SharePoint query language, and you'll find all of the different all of the powerful details there that you get access to when you come here to the query object model. This does require full custom integration. You're not doing this on your standard Search Center. If you want to do something on the standard Search Center, then you're probably going to have to get in and you're probably creating your own web part that's interfacing or talking to it, the other items, but you're not necessarily doing that in full depth. I'll get into that in a second. The third method is the query web service. People frequently will say, well, wait a minute, FAST used to be, well, it was a Norwegian company, and 60% of its install base was actually on another operating system. And, so there was a lot of market understanding of what FAST was, and they're not necessarily using Microsoft products for doing their integration. Well, great, you've got a query web service that you can go out and access, just doing straight XML, send it over the wire, get the results back. You have full control there too. We're going to show a little bit about each of these three right now. Again, look at fast SharePoint query integration on Bing if you want to drill into some more details on that. So first, the Federation Object Model. You've got a Query Manager object, which is that you have one per page, when you think about it that way, where you type search and you have results that get brought back from each location. So a page is going to have a Query Manager and a location list. And that location list has a list of locations that you're going to get search results back from. If you look at the standard search page, you get the main results in the middle, you get people search results on the right. Those are two different locations implemented on the same page, responding to the same query manager. If you want to write your own, and this happens frequently, people say, great, I want to pull in information from a database or a specific application that I've got. They'll simply implement the iLocation runtime interface and meet the APIs, and you can implement your own, and you can drop it in as a web part on your own page, and you have full control over it at that point. So that's the Federation Object Model at a high level. This is what's underneath that standard Search Center you get when you say create Fast Search Center in your SharePoint site. The out-of-the-box Search Center, sorry, I've already said most of this. This is the thing that is underneath that. It allows you to do multiple data sources simultaneously, as I said, the main search results and the people, and you can build customized locations. I meant to switch to this slide in the middle of that diatribe I just gave you. I apologize. Okay, moving on. We have the Query Object Model. This is a very simple example. I'm trusting that the room's small enough that people are close enough that they can actually read this. I'm just going to start at the top and talk my way down through it. First thing you do is you get that keyword query object that I mentioned on the previous slide, and you have a site that comes with that. And in that query, you're going to define the results provider. In this case, it's Fast Search. You're going to define the query text, q.queryText. Well, in this example, it was cut and paste out of an ASP page where there was a query object, which was the text field on the screen. And so I'm just grabbing the text out of that. Now, this is where that FQL goes in. This is the place where the power is in what the query is, not the fact that we're submitting it this way. If my syntax is FQL, I need to tell the object that because this is folded into a legacy API. And I have to decide what kind of result types I want to get back. I could just get metadata back. I could just get statistical information like refiners only or something like that. So I'm going to go through and I'm going to add a list of field names. The for each loop is adding a list of field names to the properties that I want to have come back on this query. In this case, I've got a collection called fields, and for each field name, I'm just going to add it to that list inside of the query, keyword query object. Next thing is going to be my sort criteria. And this looks simple, great. I can do sort by text. Well, again, the power is in what's in that text. I can say default and take what the system default is. I could put the name of a property that I want to sort by. And I can also do ascending, descending here. I didn't model it. Oh, actually, I did on the next line. Great, sort order. So the other thing that you can do here is put in a formula. There's a mechanism for putting formulas into your sort to do things like the geographic search that I mentioned earlier before, where I wanted to sort by distance. Then ascending, descending, and then I've got my sort list. I basically put those things inside of the sort list. And you execute the query. Boom, you're done. All you do is you go through and look at the tables that came back, and you figure out whether you got more than one table. The reason that you have more than one table come back is that you've got the results themselves, but you also have information about what happened when that query executed on the server and metadata about it. So, for example, I'm going to get my top 10 results back, but I'm also going to get that list of refiners, all of that grouping information over on the left side of the screen. That's going to come back in a separate table. So you walk each of the tables and pull things out and put them on the screen the way that you want. That's the query object model. Now, this is what is happening underneath the covers of the federation object model in the FAST search location. So the location that was implemented for FAST does all of this stuff for you, and it's tuned for the interface, and it's all set up that way. But this is what's happening under the covers. Nothing's stopping you from doing this yourself. I do this regularly. I'll set up my own web part. I'll go put it on the page. I'll fine-tune that exactly the way that I want, and then worry mostly about the presentation of what's coming back. Now, taking everything we just talked about for the query object model, we have the query web service example. This is doing the same thing, but instead of doing it by operating on the object, you're actually constructing an XML structure. In this case, you'll see. I need my highlighter here. The query text is being inserted in the middle, or the type is FQL. The syntax is a little bit different, but all the functionality is identical. So you've got the ability to completely control this, even if you're writing in something like Java or PHP or whatever you want to use to access a web service. You get done with it at the end, and you execute query by sending it across, and you parse the XML results back, and you look at your document. Same exact principles. Okay? So that was the query side. The next place that a developer can go in and tune things is in the relevance inside of the index. Now, this is something that I think has been presented on numerous occasions, so I'm just going to kind of talk over it very quickly. How you can, for different users, for example, I've got a person in sales, I got a person who's in delivery and consulting, they want different relevance models, for example. And so there's a lot more that you can do for the two different contexts. I'm not going to get into that. It's all administrative, purely available within the administrative capabilities of SharePoint and FAST Search for SharePoint. The other thing that happens is that you get control over all of these different attributes of the relevance. You get it on quality, on authority, on freshness, proximity of the words, things like that. All of this stuff are things that you have at your fingertips. You could do a whole session just on relevancy tuning, and it would really be for a very low-level discussion for people who really care about that kind of theory. I'll say it this way. in the 5 years that I've worked for FAST, now Microsoft, I've only tuned a rank profile once. The out-of-the-box rank profile tends to be plenty good enough for most people, and I've actually used XRank and rank in my query much more than I've used properties that I've tweaked in rank profiles. That's my customer set. Other people go out and do this all the time. Other consultants within our group go out and do this all the time. So just a personal comment. All of this has been leading up to the new part. To me, this is the piece where you're between the data and the index. Now we've messed with the UI and the results. We've tweaked the relevance and the ranking of the data inside the index. Now I want to catch that data on the way into the index. And I want to be able to slice and dice and analyze that data and be able to set up my search, my index profile, my index schema, so that I can get the functionality that I defined with my 5 questions above. So I'm trusting that you've seen slides like this from various sales presentations where we have a content processing pipeline that converts the documents. Then we do some language detection. Tell me if it's going too fast for the over the network display. Tokenization. Is it good?
Yep, absolutely.
Okay, great. We tokenize the words, looking for white space and things in Western languages. We limitize or stem the words for given languages. We do entity extraction. There are some entity extractors that you can define in FAST Search for SharePoint just by configuring some XML files. It's a limited set of functionality that a programmer is going to look at and say, I need more than that. For many business users, it's plenty if they're just doing dictionary lookups and things like that. But for people who want to get in and sling some code, we're going to talk about an alternative to doing it here. Date and time normalization, we make sure that all the formats get lined up. There's a document vector. The document vector is something where we go look at the content of the body of the document, and we decide statistically what the most interesting words in there are. And we say, hey, those are probably important concepts inside of that document. And the document vector is a thumbprint format of that we can look at and process on. Then we do some link analysis. Looking for anchor text, reinforcing authority and things. And then we map the crawled properties that came from our sources to our managed properties, which are the ones that are in the index. So this is the stage where subject from an email goes into the title field in the index, and title from the database crawl goes into the title field in the index. So a lot of linguistics going on. 85 different languages. I meant to take this slide out. I apologize. But if you look in the fine print, Esperanto is there, second line, third word, at the fine print at the bottom. I always think that's hysterical. We support Esperanto. Okay, so this is in the pipeline. Now instead of going to the right, it's going up. Not consistent, but I apologize for that. So the text starts coming through in the light blue, or an article, Dateline, Redmond, Washington, and Oslo, Norway, January 8, 2008. We want to go through and look at the things that are in that document, and we want to pull them out and tag the document with these company names, these locations, these concepts, cash tender or dates, numeric financial values, things like that. Any term can be extracted to convert into metadata, or any pattern if you program, and we're going to talk about that. But basically what we're doing is we're automatically generating metadata for your content based on the things that are defined and populated in your pipeline. Everybody knows that unless you've got really, really rigid governance around your document tagging, that users don't put metadata on documents. They will do the absolute minimum when they submit. And if it's too onerous, they won't even use that mechanism. They'll probably email the document instead of posting it to the site, or they'll drop it on a file share someplace instead of putting it into their document library. This is a way to get around that, going through and pulling stuff out of the text of the document. So this allows you to capture things in the language of the business itself. So the crawled properties, again, are the things that we're going to be populating here. We're going to do some locations and some companies and some concepts. We're going to pull all of those things out. We're going to capture them. The colored block is the field. So we have a location field and a company field and a date field and a concept field. Those are all things that are going to be, those are 4 of the fields in my index schema. And I'm now populating them by pulling things out of the text. The managed properties, those all get mapped into those fields. That's the concept we're trying to get through when we say crawled properties versus managed properties, and then extracting text to populate some for things like drill downs, for refiners, for sort fields possibly, for filtering. Again, I'm sort of back to those 5 questions. Entity extraction, which is what we're doing here, is really aimed at those refiners. Okay, so how can I get in and do something that's not supported out of the box? This is where the programming comes in. The last stage before the mapping is where you get to plug in your own code. It's called the pipeline extensibility stage, and we're about to drill into that. And aside, creating a custom. Okay, I mentioned that there are some that you can do that are provided as a standard mechanism within the product. An example of how to do that, you've got an example XML snippet there where we're defining some entities like business intelligence or CRM, supply chain, and we want to capitalize that in a normalized way. One of the limitations here is that these entity extractors are case sensitive, which was not a design choice that I personally would have made, but that's the way that the product works. And so I don't tend to use these on my implementation projects. When I'm doing an implementation for a customer, I tend to shy away from these because I want a little bit more control over what I'm doing. I'll use the pipeline extensibility stage and write my own stuff. So as the standard processing comes through, we get to that extensibility stage. It throws it out through the wall, if you will, and the brick wall in this case, to my pipeline extensibility code, which I then submit back the decorations that I want to put into the document, and then it goes to the mapper. Okay, so this is where it fits within the pipeline that we were talking about. So what that model looks like, on the left, I've got, this is probably not displaying as well as it could, white on orange, I should have picked a different color. There is a file called pipeline extensibility XML. It's in the FAST Search Etsy directory. The FAST Search is where your installation is. And what it does is that defines the inputs and outputs for your extensibility stage. So what that means is, as a document comes through, the system looks at this file and says, oh, I'm going to grab these crawled properties and put them in this input XML file here at the top. It's going to put them in a file. It's going to put them in the local load directory. And this is the only directory that your executable will have permission to read or write, basically, on the server. Then your program gets called. The command line is configured in this. We'll look at that in a minute. Then your code gets run, and you spit out the output that you want to decorate the document with. So if you want to populate some refiner fields from entity extraction, you can do that. But for every document that comes through, we've got an executable call, a command line executable call that's being run where you have to read the XML and you have to write the XML. So we want to keep this executable as small as possible. Let's go look at these files first, and then we'll talk about keeping that executable as small as possible. Let's go. So the input file, simple document, UTF-8 encoded. It's just a document element with crawled property elements that have 3 attributes. Property set, that defines your data source. So you'll have one GUID for SharePoint. You'll have another GUID for a database crawl. You'll have another GUID for an Exchange crawl, another GUID for a web crawl. You'll have a variable type, a var type. 5 in this case. I'm doing latitude again, so I want a floating point number, and we can get the documentation for this is all up on TechNet. And then you have the property name. This is the crawled property name that is unique within this property set. Okay, and then the value is the text of the crawled property field. In this case, 12.345678. So we've got a typo here because the second crawled property is also called latitude. It's supposed to be longitude.
Oops.
Oops. Yeah. Yeah. I get to say, you know, I've said this, I've given this probably 5 or 6 times, and I've never actually gone back and fixed the slide, and I laugh at myself every time. So the latitude and longitude here, you know, just examples. I put them in a different property set for this example just to make the point that you could do it. So actually, this would be a valid, it's not a, actually, this could be considered latitude from 2 different property sets. So it is a valid thing to do, but not what I was intending to show. Again, we're working on crawled properties in this, not managed properties. So the question is, which ones come in your input file? This is defined in this FAST Search Etsy pipeline extensibility XML file. It's got a run command where yourcode.exe takes the input, takes the output. This yourcode.exe, if you don't put a full path on it, and I recommend that you not do that, we actually recommend that you drop it in the FAST Search bin directory and let it run relative to that. And let it run there. But this is defining input fields. In this case, I've got the URL, which is a var type 31, which is the string. I've got the body of the document, which is, again, var type 31, straight text string. And the example here is maybe there was another string field that had some JSON data that I wanted to parse out or something that was populated by an application somewhere. On the output side, I've got my string, var type 31, my latitude, var type 5, my longitude, var type 5. Notice that I'm putting a placeholder here, my category GUID. You can create your own GUID so that your crawled properties don't collide with anybody else's. And in fact, that is what we do all the time. So instead of having your program go through and read all of those input files, load up everything that has to be loaded up, process it, and then spit it out, the output properties out the other side, we want to keep that executable as small as possible. So our recommendation is that you stand up something next to it that stays running, and all you do is catch it and throw it over, catch the results back and write them. That's what happens in this call web service exe on the left-hand green box. Catches the XML, sends it over. The web service would, you know, this is an example, and actually this is sort of this is the structure of one that we in MCS have got this platform, this foundation for being able to do this quickly, because we do this all the time. We've got a web service, we've got an API defined for it, where we can just drop stages into an XML file, and we can easily, using Visual Studio, just create a small exe with some custom code and configure it right into this XML. And we can run it through any number of stages. It all stays running as we do that. But this basic structure is something that you would want to keep track of if you were going to do this. It's much less overhead time-wise than trying to do it all, load everything up for every document that's coming in, especially when you've got external data like we're looking at here on the right. This might be a database connection, or maybe it's a large set of entities that you want to look up and you want to keep in memory in a hash table or something like that. You know, there are all kinds of reasons that you want to keep this web service running. So that's sort of the highest level. Now, this is all talking about when you're programming, when you are manipulating your data, trying to define the answers to those 5 questions up at the top. Now, I had not planned to do that, but I'm going to page back up. I'm going to see going home, and I'm going to go back to those questions again. Sorry, we're paging through. Get through that, this page. So the answer to these 5 questions defines what we need in that index schema, which we're modeling here at the bottom. The data source is going to have a certain number of those fields just naturally, but some other set of those fields in that index schema you're going to want to programmatically create, and you're going to do that in your own code in the pipeline in the way that we just talked about it. So we've kind of talked about how you do that, we've talked about where you do that, and a basic architecture for a recommended way to do that for being the most efficient in terms of using the time, because it is calling an executable is an expensive process, so you want to keep that as fast and as small as possible. So, hang on, there we go. So we've been talking about the logical architecture up until now, and where things fit in. When you're writing a search application, a search-driven application, and you've got a complex data model, you might find that you don't fit as many documents on a server as you see documented for the normal installation and the normal index schema. So, for example, if you've got a very, very large index schema and you've got a lot of big entities in there, you're going to get less documents per server. You're going to need to expand out your rows, or you're going to need more columns in each row. I'm trusting that you're familiar with Fast Search enough to know that rows and columns. If not, I will go into that. Carlos?
How many people understand the whole row column grid setup for Fast? They do not. Please explain it.
Okay, right. So each row, Fast it's a multi-server implementation. The smallest possible implementation that you would have would be 3 servers. You'd have an administration node, and you'd have 2 rows, 1 column. That way you're going to get search fault tolerance. Each row has a full copy of the index in it. So in this example, I've got 4 columns and 2 rows, so 25% of my index is on each of these columns, and I've got 2 rows so that I can serve queries out of either one, get the same results all the time, and that helps me either scale for query volume. So if I've got a public-facing site, I might want way more rows. If I'm selling, concert tickets or something like that, I've got a high volume of queries coming in, I'll want more rows. If I've got more data, I'm going to want more columns. Now, it's a relative term to say more columns, because you can get 15, or in standard mode, you can get 15 million items out of a typical SharePoint implementation on one of these columns. And that usually covers a lot of the departmental level and small applications. If you do high density mode, because you know that you want to maximize your documents per server, you can get about 40 million. And this is, again, all straight off of TechNet. Now, on the left side, we've got query and result processing servers. So each of these servers in the middle, the search and indexing nodes, handle a portion of the index. The application up front, the search page, is going to talk to one of these query and result processing servers, which sends the query to each of those columns in a particular row. So we catch a query, we send it to each of those 4. They each send their results back to the query and result processing server, and it decides, okay, great, I need to sort the documents this way, and then send the result back. So on a large implementation, and I would consider this to be a medium-sized one, you might have query and result servers that are dedicated. Typically, I put that process on column 0, as a default until I see the need for moving it off of there. Now, when you're crawling data, remember, you've got binary documents that are being converted to text. That's a very CPU-intensive process, and that's what these guys down at the bottom are. Basically, these are dedicated servers for doing just those conversions. Again, in most implementations, I would configure those document processing processes over here on the search and indexing nodes and do double duty. But in a big index, or if I have a particular performance requirement that, because there will be some contention if I do that doubling up, I might want to pull those out into a separate set of servers. One of the coolest things about FAST is that you can sling these processes around pretty easily. Not in a live system, but I mean when you're architecting it, when you're designing it, you can say, okay, great, I'll just move this over here so that I get the maximum performance, or I'll put these things together because I know that I'm, able to do that. You've really got a lot of flexibility in doing that. So when you're writing your application and you've defined your index schema, you've answered your 5 questions, you need to determine what kind of load, how many documents can I put in each one of these servers, how many do I have, what's my growth rate going to be for the next year or 2 years or 3 years, how large of a footprint do I need in my server room to be able to do that. So that's why we're talking about that, is that your index schema can affect how many documents you get on it in each column. Clear as mud? Okay. This is particularly awkward for me because I can't read body language and I'm not seeing. So okay, and that's basically that basically describes application development inside of FAST Search for SharePoint. I don't know if there are any specific questions or whether I've just numbed you to death.
Not at all. I'm standing by the notebook now. Question?
I have a question. Query object model, the difference between FAST and enterprise search.
Query. Did you hear that? It's about the query object model.
Yes.
So what's the difference between enterprise search and FAST search from the query object model perspective?
Oh, okay. Hang on a second. I'm going to go home. Let me.
No,
I'm
you
not
can't
in.
go home.
No, thank you. Okay. Let me come back to the example that had the source code on it. Sorry. I'm not actually in PowerPoint here. I'm presenting it through link, so I don't have the same jump straight to the. Okay, here we go. In the query object model, when you're dealing with SharePoint Enterprise Search, you would define a different results provider here on line 3. Not that I have line numbers. Instead of, you'd say search provider. And you'd put a different value there, and you would also not put enable. You'd set enable SQL false. Yeah. But other than that, it's the same. The difference comes in your query text. You don't get FQL support. You only get KQL or keyword query language support when you're doing that enterprise search. Cool. So from a programmatic standpoint, the concepts are all the same. You'll get a different. You obviously won't get the deep refiners, but you'll get just the regular enterprise refiners based off of the top few hundred results. They're not deep refiners like you get with FAST. That's something that I may not have gone into. When we're talking about the drill downs in FAST Search for SharePoint, you're getting exact counts through the whole result set. You're not approximating it off of the top few results, which is key for a lot of applications.
Cool. Very good.
Anything else?
Questions?
I have another one.
Please.
I just heard about document vectoring.
Yes.
Is the correct name?
Yes.
What is the process under the hood? Is it based on index and algorithm, or is it parallel processing with multi-threading? Just curious.
Can you talk to the doc vector stage?
Yes, the doc vector stage. I'll come back to.
She wants to know whether or not, what sort of algorithmic implementation, or is it multi-threading? Is it sheer algorithms? What kind of processing, parallel processing?
Index-based.
On the interface, I'm misunderstanding. The doc vector is just a string. It's just another field in the managed properties constructed out of.
Can you talk about the stage, the vectorizer stage?
Oh, it's single-threaded. It's an algorithm that goes through and looks at statistically interesting things in that text. So it's going to throw out things that are really common. Right here, there we go. And so, the word "the" is never going to be one of your concept terms there. And you're basically isolating the top 3, 4, 5 terms or phrases in the document, but I guess you're asking how this is implemented, or?
So, for example, what sort of overhead is there involved?
Oh, in the doc vector stage?
Yeah.
Oh, I've never seen it being a problem. I've never been asked that before.
It can be useful, huge amount of data we discover, for example, because there are a lot of third-party products that do multi-threading and parallel programming very fast. How it works.
Right. For this, it's really going to work just in the .NET model, so it's just going to be single-threaded. It's going to have whatever the normal overhead is, and so on. Yeah.
Right. Now, the place where, hang on a second, the place where you pick up your multi-threading when you're talking about document processing, and I'm jumping around in my presentation, I'm going to my physical architecture slide. Actually, I'll go to my logical architecture slide. This square here on the, you can't see where I'm pointing, says item processing. It's in the FAST Search server box in the middle.
Pointing it out.
Right, pointed out, item processing. This is where all of your document processing occurs, where all of this pipeline stuff happens. Now I'm going to change down the slides. The crawling and content processing are these 4 servers at the bottom, but these are processes that you can identify how many processes you put on each server. Generally, you're lining them up with your CPU availability, so if you've got an 8-core box, and you want to dedicate that for content processing, you might put 6 document processors on there, leave 1 or maybe 2 for overhead and other activities, but that way you'd have 6 separate threads where you could be converting 6 documents simultaneously, because document conversion is a hugely CPU-intensive process. This is why people might stand up standalone servers for doing document processing if they've got a good query load. If I've got a light query load or a small data volume, I'm dropping those document processors all over the extra. I'll put 2 on each of these search and index boxes, and if I've got enough cores, I might put 4 on each, right? So if I've got an 8-core box, I'll probably drop 1 or 2 document processors on each of those search and indexing nodes, and that would give me, in this case, 16 document processors, and that will increase my throughput. Now, the next big thing on the physical architecture comes down to how many document processors can I support? At what point do I have so much coming through that my disk where I'm indexing the data on those servers can't keep up? And on a well-tuned index, the issue always should come down to disk I/O on the search index boxes. So in terms of throughput, document processing, doc vector, document conversion is actually the stage that you care about. That's the one that's the bugaboo.
So just as a rule of thumb, right, we're looking at about 2 document processors per core. The typical configuration is dual quad core. So we're looking at 8 cores. If you put 2 docs per core, then we're looking at about 16. Right, if you have to, right? Because by default,
if you have to,
and then if you need more, you just kind of keep piling them up 2 at a time per core.
Yeah, exactly. And I usually start at 1 per core. That's usually where I start, and then I'll dial it up or down depending upon how my disk I/O is or those kinds of things.
Any other questions?
Was this informative?
No, that's your question. I have another one over here first.
Oh, sorry. Okay.
I was just going to say, all of this be virtualized, or it needs to be physical?
Can all of this be virtualized?
Yes, it will have a significant impact on your performance, and the reason I say that is your primary bottlenecks are threefold. 1, how fast can you pull stuff out of the source system that you're crawling? 2, how many of these document processors do you have support for? We're lining them up with your CPUs, and if you're on a VM, people want to do VMs because they want to overload their servers. They're not going to dedicate necessarily the VMs at a 1-to-1 level and things like that. So you're going to get an impact on your performance there. And then the other one is on disk I/O. FAST is a hugely disk I/O intensive process when you're crawling and when you're querying. So that means that each server in this 4x2 grid here needs to have a big fat bandwidth onto its disk that's not affected by the server next to it. When you're talking about VMs, you're usually talking about a SAN. The people who manage the SANs in most organizations don't think in terms of this use model. They think in terms of typical intranet or corporate use, where you've got end users accessing files and the SAN optimization algorithms for doing read-aheads and stuff like that all make sense. The usage pattern here is a SAN manager's worst nightmare. And I've had people from name brand SAN manufacturer vendors say that when I've explained what happens. Because when the query for the word "the" comes in, every one of those servers in that row are going to light up their disk completely looking for the word "the." And if the SAN on the back end has spindle contention across those, or if there's not enough fiber channel between the chassis or the VM host between there and the SAN, there are all kinds of places where you can get a bottleneck there. So you'll see a performance hit. If you're reading between the lines, you're hearing me say, you really don't want to do that, can you? Yes. General Custer also had the option of going down, to the Little Bighorn that day.
And just as a rule of thumb, typically if you've got more than 8 million documents that you're indexing, you probably should not be going on a VM. But again, there are all sorts of caveats to that, so you still want to be able to look at things. But
yeah.
It's supported, but.
You know what? I say all that because I'm a search snob, and I want a high-performance, snappy search, and I expect a certain level of throughput and things. There are many use cases where, what I would consider to be a terrible performing search, meaning I've got a 5 or 10 second query latency, meaning it takes 5 seconds to get my result back, or I can only handle a couple of queries per second throughput. You know what? There are environments where that's the use model, where that's the usage profile. That's fine. And I throw those out as examples, not as hard and fast rules of thumb. But I'm expecting that index to respond sub-second, so that most of the time on my search results is actually on page rendering. That's the kind of thing I'm expecting when I'm installing something.
Very good. Any other questions?
Questions.
Thank
you for moderating for me.
No problem.
So, okay, Steve, I guess that's probably it then for the talk. I'm going to hand things back over to Jamise, and she'll start handling the next stage.
Thank you. I'll take that as a good sign.
Yes.
All right. Did anybody throw anything at you, Carlos? We're good.
No, but then I was under the table.
Got it. Thank you all for listening, and thanks for the opportunity to talk to you. Bye.
Very good. Thank you.